let's just take the best thing we can see on the table and not even think ahead, not even plan ahead. Let's be a greedy algorithm. So, as an example, suppose that you want to make $2.65 using Australian coins. One strategy is to just build it one coin at a time, just always picking the biggest coin that doesn't go over. Not even thinking ahead, just thinking in the moment, just being greedy in the moment. So we want to make $2.65. Our greedy strategy would say, well, what's the just biggest coin we can put on the table that doesn't go over? Let's see, let's put a $2 on the table. So I've got $2 on the table. I still need to put 65 cents extra on. Well, let's just be greedy again in this step. I'll put the biggest coin on the table that doesn't go over 65 cents. $2, no, too big, dollar, too big. 50 cents, there we go. So now I've got $2.50 on the table, and I still need to put 15 cents on the table. Well, let's just be greedy again, put the biggest thing on the table. Not even planning ahead about how it might impact us later. Let's just pick the biggest thing. $2, no, dollar, no, 50 cents, no, 10 cents, there we go. 10 cents is the biggest coin that doesn't go over. Just the best choice in the moment without planning ahead. So that means that I've still got 5 cents left to give. Again, greedy, I'll just pick the biggest coin that doesn't go over 5 cents. $2, no, dollar, no, 50 cents, nah. 10 cents, no, 5 cents, there we go. Oh, look at that. I came up with a solution. A $2, 50 cent, 10 cent, and 5 cent brings me to $2.65. And I used the greedy algorithm to get me there. But was it the best solution? Well, as it turns out, for Australian coins, it will always give you the best solution. It is guaranteed for this specific combination of coins that we have in Australia. So, that is an example of a greedy algorithm, which builds a solution step by step and always just choosing the option that looks best at that moment without planning ahead. Nice, simple approach. You don't have to think too far ahead or backtrack when you make a problem, when you find a problem. And for some problems, the greedy algorithm is guaranteed to find not just a solution, but the best solution, the optimal solution. For other problems, it might find a suboptimal solution, a solution that is okay, but not the best. Or it might find no solution at all, even though there is one. As an example of when it might fail, we can use the greedy algorithm for a maze. The greedy algorithm is often the sort of naive solution, the simple solution, where you don't think too hard about planning ahead and all the different possibilities. It's just that whenever you're faced with a decision, you pick the best decision in that moment without planning ahead. If we have a look at this maze here, then I might just try to pick whatever choice gets me closest to the exit in any moment. So I'll start here, and then I'll go I'll go down because that gets me a little bit closer to the exit, and then I'll go, well, I have no choice but to go here, or where do I go now? I'll go down because that gets me closer to the exit, and then I'll go along here, and I'll go down again, and I'm stuck. I fell into a trap. So you can see that here, the greedy algorithm does not work for this kind of problem. It fails. It doesn't find a solution, even though there is a solution. So, in summary, sometimes it's guaranteed to find the best solution. Sometimes, for some kinds of problems, it might not be guaranteed to find the best solution or a solution. And that's a greedy algorithm. Be greedy.